All right, so we're going to look at perfect squares. And what perfect squares were, the difference of squares, we had that conjugate pair where the sign was in the middle. Perfect square starts out with a plus sign, and the whole thing is squared, which that gives us a squared plus 2ab plus b squared. Remember, our game is to move from the right-hand side back to the left-hand side. And also, our friend here, a minus b, which has the same pattern. But remember, the middle term is the key here. In the middle term, the sign is different, 2ab. And the thing that really makes perfect squares stand out is this doubling, this factor of 2. So when we see a perfect square, we're looking for a factor of 2. So these are the exercises 21 through 32 in your textbook. And so let's start by looking at 22. 22. So I have a y squared minus 10y plus 25. All right, so my pattern says that if this is coming from a perfect square, that this is going to be twice what a and b are. Twice a and b are. Well, how can I check? Well, I'm going to check to see if this is a perfect square. So a squared would be y squared. So plain old a is y. And b squared is going to be 25. So plain old b would just be 5. Just 5. Now, that 2ab, that middle term that we're hoping this is, would be 5y times 2. 5 times 2 is 10. Y. And so this is really my check here. Do I have that? Well, I do. So I know that it's my a, which is y, whatever this sign is, minus my b squared. Well, let's check that. Y minus 5 times y minus 5. So first gives me y squared, outer gives me 5y, inner gives me minus 5y, last gives me 25. And when I combine these middle terms, there's 2 of them. It doubles, right? 2ab. So I get y squared minus 10y plus 25. Hey, that's what I wanted. So, well, that's where I started from, not what I wanted. So I know that this technique is proper. So it works out nice. I want to actually break mold a bit here and see one that isn't quite a perfect square. So I want to jump over and look at one that looks close to a perfect square, but isn't. And what we'll do is we'll just take the same thing we just looked at and we'll alter it a bit. So we'll go y squared minus 12y plus 25. Well, we know 25. We'll say a squared. I was going to say we know 25 squares 5. And that's what we're looking at is our ends imply that a would be y, and b squared implies that b would be 5. Right? So if this is going to work, the square roots of these things are going to be a and b. But we want 2ab to equal 12y. Well, when I multiply 2 times 5ny, 2ab does not equal 12y. It actually equals 10y. And so that's the word this doesn't work as a perfect square. And that's how we check. So when you have a polynomial and those two ends are perfect squares, right, both sides, you take the square root, mush them together, multiply by 2. And if that's your middle term, it's a perfect square. And so you can use this pattern. So it's a two-step check, but it can save you some headache when you see our other forms of factoring polynomials. If it's a perfect square, this goes really quick once you recognize the pattern. And you'll get used to your squares. 1 times 1 is 1, and then 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So when you see 1s, 2s, 4s, 16s, 25s, 36s, 49s, 64s, 81s, see I'm listing all our square numbers. When you start seeing those numbers playing in your coefficients, you can try to go to this root. And so those patterns will come up. And always having a good pattern helps save some work. So let's look at another perfect square here. We'll look at 28. So 28 is 25x squared minus 20xy minus 4y squared. So I want to do this test. I'm going to try not to write it all out in equations. I'm going to just look at my ends. Is this a perfect square? Well, that would be, the square root of that is 5x. So we can say a would be 5x. How about this over here? Let me see, and I apologize, that is not a minus sign, that is definitely a plus sign there. I thought I drew it, but the pen didn't pick it up, or I went way too quick. But it should be plus 4y squared. And so is that a perfect square? Well, the square root of 4 is 2. This would say that b is 2y. And so I need my middle term to be a times b times 2. Well, I have the x and y in there, which is good. And so I know a and b are in there. But what about the 2 part of it? Well, 2 times 5 is 10. And 10 times 2 is 20, right? So 2ab equals 20xy. That's what I have there. So yes, this is a perfect square. I can go right to my pattern, which is 5x, my a, grab my sign, negative my b squared. And I factored it. And this is the pattern of perfect squares that we can use. So we have a difference of squares when it's just 2 terms that are squared with a minus sign. These perfect squares are 3 terms, and the middle term has that doubling factor. Remember, the middle terms really are key to a lot of things here. Difference of squares, the middle term has vanished. Perfect squares, it's a double of what's going on. And we'll look at our cubes.